going to be looking at these simulations from this EPW. So if we start with the first question, write down the instruction code necessary for your ClassPad calculator to generate a random whole number or integer between 1 and 30 inclusive. What would I put into my calculator, Ben? Rand 1, 30. So that picks a random number between 1 and 30. Okay, what about for B, 16 and 20 inclusive? Quinton? Perfect. All right, so I don't know. No idea. So we just need to be able to use that round. If I said I wanted to have a list of 5 numbers between 16 and 20, what would I write then? Mitchell? Yeah. So something like that. If I want 5 numbers, instead I use rand list, and I go with that. Are there any questions about that? So that's just a review of yesterday. Because you can use a different system which might need 3 marks, but we're just using this one, so that's fine. Doesn't matter. Yep, if you wrote that first bit, you'd still get the marks. Okay? All right. Not going to happen in your test, which I write. All right? Okay, so next one. 2 seconds. Okay. If you were to use, so it doesn't say you have, if you were to use your ClassPad or an Excel spreadsheet to generate question 1B above. So that was rand 16 to 20. How many 17s do you expect to produce? So, how many numbers are there here? 5. So how many 17s? What's the probability of getting a 17? 1 over 5. Now, how many times did we generate it? 100. So how do I then work out how many you think there would be? Times 100. So you'd go 20. How many 20s do you expect to produce? Same. How many 15s? 0. Why 0? Because we're only generating numbers from 16 to 20 inclusive. Pretty easy, yeah? All right, so that's easy 4 marks. Let's move on. Question 1B above has been generated 100 times. So again, what were the numbers? 16 to 20 inclusive. So, got to remember that it has been generated 100 times on the spreadsheet shown. Circle and count the number of 17s you can see. Did mine get cut off? Is there more? So how many are there? 22. Everyone agree? Good. Compare the count in A with your answer in question 2A. So, we're saying that there were 22 numbers which came up, but we predicted that there would be 20. Saying compare it. So what would we have to do, Joe? No? Good. So our prediction was 20. In actual fact, it was actually 22. Why were they different? Because when you actually do an experiment, you're going to get different results to what you theoretically assume to be the probability. Okay, so the top one's called theoretical probability. It's what we expect. But when you actually do an experiment, it's going to be different. But we're hoping that the more times you do the experiment, the closer it's going to become to 20. So if we generated 1 million numbers, we would hope that overall when we found the average out of 100, it would be closer to 20 as we go through. So the more different repeats you do, the closer it will come to its theoretical probability. But it's not going to be exactly the same because this is a real experiment. That's theoretical. All right? Okay, let's move on. The tossing of a coin is simulated 500 times by generating a random number of zeros and ones. Oh. Oh, sorry about that. Okay, 0, etc. All right. So, where 0 represents obtaining a head and 1 represents obtaining a tail. Okay, so 0 head, 1 tail. The first few generations are illustrated to the right. So, for example, 1, 1, 0, 0, 0, 0, 0, 1, 0. Okay. The long column is then added up to give a total of 252. What does that 252 mean? Yeah. Yes, but that's not exactly what it is then. There were 252 heads obtained. The tails obtained, sorry. Okay, because tails were 1. Thank you. All right, so 252 tails. Okay, and therefore 248 heads, okay? No, because it only asks you what the 252 is. All right? What theoretical probability, so theoretical probability means in theory, not the experiment, in theory, do we usually assign to obtaining a head on tossing a coin? 1 over 2. There's one option out of 2, right? So we'd say half. Based on your answer to part A, what probability would you assign to obtaining a head on tossing a coin? Zen? 248 over 500. Why is it different to a half? Why isn't it 250 over 500? Yep. Because it's a practical experiment, it's not theoretical. Okay? Pardon? There's different, yeah, true, but there's lots of different ways of, like, so in an experiment, you don't have to come exactly to the theoretical probability, okay? There will be small differences, especially if you only do a couple of experiments. All right, for homework, you were asked to have a look at this overbooking scenario, okay? Some people, everyone said, well, there wasn't much to do because you just need to read it. So you should actually understand this as long as you've read it. But we're going to read it together and make sure you understand it, okay? Simulation 1, overbooking in Chapter 7 of your 2D textbook, considers the consequences of a 25-seat capacity plane. 25-seat capacity plane. Being overbooked by 1, where 1 in 15 customers cancels at the last minute. Below, 10 flights have been simulated using Excel's RAND between. So that's just saying it's just got a list of numbers between 1 and 15, with the late cancellations represented by 15. Now, this actually happens. When I went on holidays about a year ago, I was flying from Ireland to New York. I got to the front of the plane and they said, we're overbooked. Would you like to take an hour later Delta flight, whatever, and we'll also give you £200, euro, whatever they have at the time, 200 euro. Okay, so they actually do this, and a lot of aeroplane lines do this a lot because they end up going, well, if one person cancels, then they've got a full plane. If one person doesn't cancel, well, then they're out €200 or something, but they're actually saving money in the end. Okay, so this is actually real. And this is how they do these simulations as well. Zen?
Yeah, I was just
I didn't because I was meeting someone in New York and they'd already left, so I couldn't actually tell them what plane I was on.
So how'd you get there then?
Pardon? I took my same ticket. They said so I had an option.
Oh,
They were just trying to get people they needed to get at least a couple of people off. Yeah? So no, I didn't. I know I thought about it, but I didn't. Anyway. All right. So, if we... Oh, it's cut off again. Why is it cut off? All right, can someone tell me what the last numbers are? Because this is kind of important. 7. On your sheet. Q, R, S, T, U, V, W, X, Y. 9 numbers. We can write 9 numbers. We're just going to do one roll across to start with.
11, 4.
11, 4,
3,
3,
10,
10,
11,
11,
3,
3,
7,
7,
11,
11,
7.
7. Perfect. All right. So So what this is saying is, it's a 25-seat plane. 25 seats. But instead what they do is they book 26 people in. 26 people in, even though there's only 25 seats. Because they know that there's a 1 in 15 chance that someone is going to cancel. Because there is a 1 in 15 chance, they go, okay, if we allocate each person a number randomly between 1 and 15, if we hit a 15, that person cancels in our simulation. So for this first one, was this plane fine or was it overbooked? Were there 26 passengers or were there 25 or less? It's fine, it was 25 because this person cancelled. All right. In the second row, can you guys just tell me if there's any 15s in the second row which I've missed? No, okay. In the second row, how many people took the plane? 26. So what happened to that plane? It was overbooked. Okay, in the third one, what happened? Is there another 15 we're missing? No? So, how many 15s are there? Maybe I'm missing one. There's 3, so how many people took the plane? So it's under capacity, right? That's okay, it doesn't matter. Thank you. So it's under. And it's 23. So this one was 25, overbooked 26. All right, what about the next one? Number 4, there's 2, so under how many people? 24. Next one? Just the one, so it's perfect. Capacity, 25. Number 6? Oh, there's 3, so it's under at 23. Is there another one underneath, or is that it? There's a few more. All right, can you guys understand what's going on here? Can you see why an airline would do this? If you think about it, a lot more of them at the moment, I don't know about the ones underneath, are actually under with a 1 in 15 chance than overbooked. And if you think about a 1 in 15 chance when you've got 25 people, there's quite a good chance that you're going to have at least one person who cancels because there's 25 people. Yeah? Pardon? They work out that chance from previous plane flights. So all of these sort of, anytime they give you the percentages for these sort of simulations, it's based on previous data. So it's based on, they've done some research and found that this is the percentage of people who usually cancel. And that's how you can use that data. And they use these sort of simulations in quite a lot of real life scenarios. Okay? All right, so can you guys finish the last couple of them and answer the questions? How many? How many? How many? You don't need to do B because we haven't actually used that little machine. So you just need to answer A. You just need to finish the rest of those lines off and answer A. And we're going to leave it at that for simulations.